All right, everybody. Good morning to you all. I hope you guys are doing well. Let me get this pen up and running. Okay. All these little details. Anyway, okay. All right. So today's Thursday. Thank you guys for being here. You guys are aware that yes, we do have a lecture and that tomorrow is Veterans Day, right? And the campus is closed tomorrow, not today. Sorry about that. So, I think what we'll do is we'll just take a look at this. Okay, here is this class 241. All right, so we're here at 241, and, well, I guess we're looking at this over here. We're looking at you guys over here. Now, last night, like I said, I was going to update your study guide. Is that right? I was going to put the correct version because it looks like there was an incorrect version up there. So now I have a correct version. Let me see if I could do that. But we got to use Heron's formula. But let's go through this here for you guys, okay? Oh, use Heron's formula, okay? So I'm going through this, looking at this stuff here. So there's a couple of loose ends I want to go through, all right? You guys see what I'm saying? So I did delete some things. Hey, why is it still? That's an odd thing. Can I refresh? Oh, I should have checked at home. Let me see if I can do it here. Okay. So give me some time here, or I'll do this. Here's what I'll do for certain. Okay. If I go back here to let you guys know, let's look at the textbook. Okay, we're gonna do Heron's formula. Now, I'll give you guys some work to do. I'll try to update it here if I can. I might be able to. Okay. So we're talking about Heron's formula. Now, essentially, Heron's formula, I remember, is in law of cosines. Okay? And you cannot see. So we're in law of cosines. I hate that. I hate that it did not update that. I put that, I made my wife angry at me, like always. You guys know what I mean? So, Daniel, are you working again? Yes. Sorry, Mrs. Judge. Yeah, I know. Isn't that horrible? You're in a meeting and we couldn't go to Costco and now you're working again. I go, you don't understand. I got these students and they're studying hard and they're wonderful, wonderful people, and they can, they want to see this updated. They want to study and work hard. You don't get it, Mrs. Judge. Sorry, I shouldn't be saying that, but it's true. You guys know what I mean? So, I think, look, it's wonderful to even be here in the morning, and I think you guys are worth every ounce of what. It's not even a problem for me, but it can be so for others, but I apologize. Anyway. And I want to prove this to you guys. Well, maybe I will, maybe I won't. But what I'm going to say to you guys, go back in the book. I'll share with you where this is even. And textbook. I know you should never say things about your wife. Nobody likes that, but nobody appreciates. That's not good. Don't follow Mr. Judge, ladies and gentlemen. I tell my daughter all the time, Ashley, don't be like your dad. Please, you're gonna get in trouble. Don't be like your father. All right. So remember, where's law of cosines? Right in here, right? So I want to remark. Here's Heron's formula. Okay, let's go all the way down. If I can find it. Navigation. And I want to put some navigation too. So, okay, maybe, hey, whatever. All right, you guys see this here? Let's make it bigger. All right. Well, you know, the proof's in the book. I did want to prove it to you guys. But there's actually two formulas, if you guys, for area. And this is Heron's formula. Now, Heron's formula is saying the following here, okay? Notice you have to have, if I go back here, here's in my mind. You got A, you got B, you got C. Remember, you got all three sides, right? So this is kind of like going, oh, okay. You got side, side, side. Okay, so you got side, side, side. Now, Heron says when you have side, 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 here's my area formula, okay? I'm going to write it down. Your area is going to be the square root of S minus A, S minus B, S minus C. Okay, so I'm going to go back here, and you go, okay, I get it. You have A, you have B, you have C. You have the three what? Sides. Is that true? Okay, okay. But then the question is going to be this, okay? What is S? So S, ladies and gentlemen, is called the semi-perimeter. Okay, and give you the definition. And we'll color that purple, I guess. So you got the semi-perimeter here, S, 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 and S. So the semi-perimeter S looks like this, right? S, well, what's the perimeter? Do you guys know what the perimeter, by the way, of a rectangle would be? What's the perimeter? If I said to you, can you give me the perimeter? You know what you do? You add all sides, is that right? So the perimeter is the sum of all sides here. Okay, and you're going to divide by 2. So we call this the semi-perimeter. So this is what you actually need as well. Okay, so this is what we call, this is actually an area formula. It gives you the area. Gives you this area. That's the area. Okay, but make sure you get this A, B, and C. All right, you guys okay with that? So, for example, and I'll look in, and you know, I want to do more of a realistic example, because the truth is, you got to be careful. And you know, here's actually the proof. If you said, what's the proof of this? Right? It's based on this formula here, back with the law of sines version. Right? So Heron has, there's a law of cosines version. Copy. And then I'm going to say this to you, just so you guys know, by the way, you want to know this too, that you also have the law of sines version. You go, we do? Yeah. Yeah, we'll get that. And we have a law of sines version. I'm just trying to clean this up here, okay? It's not called Heron, so you have the law of sines version. And the law of sines version is not based on side, side, side. That's law of cosines, right? But I think they label it, you know, Well, I just want to make this clear. You got theta here. Okay? You guys remember this one? I think I did mention it. But if I didn't, here we go. Notice, why is it law of sines? Because you have side, angle, what? Side. Okay? Easy breezy, lemon squeezy? Okay? So do you guys remember what that formula was? Maybe? I thought we wrote it down. It's AB what? AB sine theta. Okay? Now, I don't think, though, it's in the formula sheet. So if I said to you, remember you have your cheat sheet? I don't think they have that here, these formulas, by the way, for area on the cheat sheet. Okay. By the way, there's a lot of triangles. Anyway, so let's go back to the iPad. So then the question becomes like the following, right? How do we use these formulas here? So I'm going to have you guys compare and contrast here. Right? If they give us something like 52 degrees, 6 meters, and 10 meters, okay? Identify something here, right? What do you guys identify? Side, angle, what? Side. Is that true? So if that's the case, and they ask you, hey, you know, what is the area? What do you guys do? It's AB what? AB sine theta, is that right? Yeah, yeah. To find out. Good ass, Siri. Okay. So here's the deal. A is what? 6. B is 10. And then you have sine 52 what? Degrees. I think it's Francisco. Is that right? Some Paco Francisco? Anybody know? Maybe. My wife's not even gonna know. She says, what are you talking about? So if I said to you guys, what would you do now for the area here, right? 60 sine what? 52 degrees. Okay, I'll go back. Remember, how do you want your calculator to be set? Set calc to what? To degree mode. Okay, make sure it's on degree mode. Because if you put it on radians and you try to use it, you're gonna have a problem, right? Okay, you guys with me on that? You guys understand? So this is gonna be what? So this would be what? 60 sine what? 52 degrees. And what is this area? Yeah, I'm going to say it's approximately 47.2. Okay, and we're going to say what now? Put units squared. Okay, impress your science teachers, because if you just give a number like 47.2 for area, those science instructors will be mad. Yes. Oh, did they give meters? Yeah, they give meters. So make sure you put meters squared. Units is in general. If they don't give, if they give only a number, that's general. So yes, you want to say meters squared. Okay. Okay, you guys okay with that? What do you guys think? Is that a pretty good formula? I thought I proved this to you guys, and we did right triangle. Right. Oh, we did this law of sines. You guys remember that? Is it in your notes, by the way? Good. Okay. Then I did do it. AB. What do you mean? AB over 2? 1 over 2 AB sine. Okay, good. So I have to wake up with that. And so you're saying this is going to be what? So 1/2 AB sine theta. Is that true? Okay, and that's in your notes? And textbook. Good job. Thank you. So what do you have to do with this then? Then this is going to be now what? One half. So 1/2 times 60 is 30. Okay. And so now you can say, well, what is it? Let's go to the TI. Clear that out. Thank you. 30 sine what? Sine 52 degrees. And that'll be 23 point what? 23.6. Meters squared, actually. Okay, so I apologize. That's 1/2. So let's go back here and put the 1/2 here, okay? Because I can prove it all over again if you guys like, but I don't think that's necessary. So remember, this is a side angle side version. So in one case for like in your study guide, and I'll find the correct one in my notes, that's really odd. That's crazy. It might be, let me go double check. I don't want to say. In Canvas, if you actually upload a file and then you go back and try to upload it, overwrite it, and that's what you do, you overwrite a file, and it has the same title. I'm wondering if it just doesn't understand that you have to delete and then re-upload versus upload and upload. But it says, hey, do you want to delete it? And you say yes. And anyway, it's a whole thing. So I'm going to look into it right now as soon as I can. Now, compare that to Heron's formula. So now if you're in a law of cosines mode, I mean, and you don't have, like if you don't have this angle here, you go, hey, I don't have that angle. It's not even listed, but I have all 3 sides. You guys see what I'm saying? I got all 3 sides. Heron's formula. But you want to remember the definition of semi-perimeter. Semi-perimeter is just like saying half perimeter. So that word semi is code for what? 1/2, okay? Like semicircle is code for what? 1/2. Okay? So for example, now you say, well, what is this here? You know, if they gave you, okay, this is going to be now maybe 20 feet. And this maybe looks like 16 feet. And this is maybe 12 feet. Okay? What do you guys notice here? This is what? 12 feet, 12 feet, 16. This is my side, what? Side. And they want area? They want this area formula? Okay, not a big deal, ladies and gentlemen. Always get the what? Semi-perimeter. 12 plus what? 16 plus what? 20. Divide by 2. So we're going to get this S value. Now divide by 2. And what do you get? Yeah, let's go back to that calculator. You get 24 for the semi-perimeter. Is that true? Okay, so remember, so what did I do? I added those values and divided by 2. If you want to do it directly, here, use this parentheses here. Right? 12 plus 16 plus what? 20 divided by 2. It's 24. Okay, and here you go now. You say, what in the world is Heron's formula? It's actually a nice, easy formula to remember, okay? Let me write it down. I have this memorized too because it's kind of an elegant formula. You write down S, and then S minus every side that you have here, okay? So you found S. Okay? And then you now have A, B, C. So what's A, B, C? 12, 16, and 20. Okay? So 12, 16, 20. And then you have what? 24, 24, 24, 24. 24. 24 minus 12, 24 minus 16, 24 minus 20, okay? Okay, because you need A, B, and C, right? This is, doesn't matter what you call them. You could say A, B, C, whatever, it doesn't matter. So you have 24, 24, 24, 24, and then you have all the values. A, B, C. So here, you get what? 24 times, what's 24 minus 12? Do you guys know? 12. What's 24 minus 16? 24 minus 20? 4. That's all under the radical. All right, so let's go to the TI. You're going to say what? Second square root 24 times 12 times 8 times what? 4. And square root of that number, the answer is what? 96. So if you say, what in the world is this? So my area is approximately 96. What are the units again? Okay, so you say square feet, and you could put it feet squared. All right, okay, you guys okay with that? Is that easy breezy lemon squeezy? All right, now here's the thing here. I want to do a few other things. I'm going to kind of look on my end. Oh, I don't want you guys to look at my files. Maybe study, memorize the what? Memorize this list. Memorize the formula sheet. All right, I'm kind of joking, but let's see if I can get this here. Let me see here if I can find in the files. Fall 2022. Okay, it has yesterday's version. Let me see what yesterday's version is. Because, you know, even if we look at the book here, what I also want to go back, you guys see these functions here. Where are they? Oh, there we go. Look at the lower right corner. Okay? Do you guys see some of these functions here? Right? If I say it to you, these are called the what? Cofunction formulas, right? Yeah, that's kind of odd. Okay, let me close that. I'm gonna have to find the file. These are called the cofunction formulas. And I'm going to write down the first one, okay? Sine 90 degrees minus theta is cosine of what? Theta here. So I'm just going to write down the first one, okay? And we're going to go over here and we're going to look at this. So how do we actually prove this? Do you guys have an idea? How can we prove that? Yeah, you might say, oh, okay, Mr. Judge, here's my left-hand side equals my what? Right-hand side. Because did you guys see that study guide version I have there has some of these to prove? Is that right? You guys see what I'm saying? So in other words, you go, oh, so, and I want you guys to know this is super easy, okay? This is easy. Don't be intimidated by this. So if we had to prove this here, left-hand side is sine of what? Pi over 2 minus theta. Okay? Okay, you guys see this here? This is a very easy thing to do, believe it or not, Okay? Anybody have an idea? Just look at that and tell me what comes to mind. What would you do? Yeah, you're using the difference formula for sine. Okay, so I might have given you guys a clue here, right? So here's my clue, just so you guys know. Go back to your formula sheet and you go, all right, what's there? The difference formula for sine. So what is sine A minus B? Do you guys remember? I'll write it down here just to kind of share with you guys. Isn't it sine A what? Cosine B minus what? Cosine A sine B. Is that right? Let's go back where you guys can see. So I'm going to say this is sine of 90 degrees, right? Cosine theta minus cosine 90 degrees, what? Sine theta. Okay, I need some room. Easy breezy, lemon squeezy. What's sine of 90 degrees? What's cosine 90 degrees? Okay, and so what's 1 times anything is itself. So that's just cosine theta. Now 0 times anything here is 0, is that right? So I want you guys to notice this. This is going to be what? This is 0. Now isn't that my right-hand side? You guys see what I'm saying? So what do we show? The left-hand side equals the right-hand side, and our proof is done. Okay? So when I say to you guys, these are the cofunction identities. That's like sine 90 minus an angle is the same as cosine. And sometimes that's used in various science courses to make your work easier. Okay? It just makes your work easier. It simplifies, because then you say, oh, just use cosine if you have sine 90 minus theta. It's kind of like out of phase if you think, it's the same function. If you want to see it in Desmos, I can show it to you. It's the same function. The graph is. So, like in Desmos, you say, what's cosine? Well, y equals what? Cosine theta, right? Or cosine x. Y equals what? Sine. I guess I'm going to have to put pi over 2. I think they want radians, right? Pi. Okay, aren't they the same curve? Aren't they on top of each other? You see what I'm saying? That's the idea. You go, sine, of 90 degrees minus x is the same as, y equals sine 90 minus x is the same as y is cosine. They're the same. Okay, so this is kind of one of the uses of these cofunction identities. So I know in your book had some, and you could kind of do some, you could do similarly if you wanted cosine, whatever. Here, let me say this. Let's give you guys an example. Have you guys work on a few. Okay, so if they gave you cosine pi over 2 minus theta for number 1, and then number 2, how about if they give you something like this? Cosecant. Yeah, cosecant. Cosecant what? Pi over 2 minus theta will become secant theta. Okay, and then number 3. Tangent pi over 2 minus theta is cotangent. Oh, what was the first one? Do you guys remember what this one is? Cosine was going to be what? Sine. So I'm going to have you guys prove these in the same way. I'll give you guys some time to do it because some of these were on that study guide. Did you guys notice? Okay, maybe you didn't notice. So I want to just clear out some loose ends. You guys know what I'm saying? And I'll look for what I need to look for. right? Yeah, you're just using the difference formula. I mean, you're saying the left-hand side is what? Cosine, you know, and you're using the difference formula for cosine. Okay? Cosine of a what? Difference. Is that true? So what is cosine of a difference? Do you guys know? It'll be what? We're going to have now cosine of what? Pi over 2 cosine theta plus or minus? Plus sine pi over 2 cosine, sine theta. So you're using that difference formula again, or it's not even the same difference formula, but using a difference formula. So remember, you get to use that sheet on your test? Yes. So what do you guys have here now? What's cosine of 90 degrees? 0. What's sine of 90 degrees? 1. And this equals what? Sine theta, which is what? Your right-hand side. All right, you guys okay with that? Okay, you guys see the point? Is that's only like 1, 2, that's like about 3 lines. How long would that take you to do on a test? I don't know. Do you guys see what I'm saying? What do you guys think? Is that easy breezy, lemon squeezy, or is that like saying no? You guys know what I'm saying? So, and what about this one? How would you guys do this one? Well, I'll say the left-hand side is going to be what? Cosecant what? Pi over 2 minus theta. And then you're going to tell me, you know what? There is no what difference formula for cosecant. Is that true? We don't have a difference formula for cosecant. How do you do that then? 1 over what? Sine pi over 2 minus theta. Okay? Now, what would you guys use? This is sine of a what? Difference. So now go back and look at sine of a difference. Did we have that? Yeah, it's sine cosine minus cosine sine. Sine cosine. Minus cosine what? Sine. Okay? So this is what we're focusing on in the denominator. So what is sine of 90 degrees? Isn't that 1? What's cosine 90 degrees? 0. And that's 1 over now what? Cosine. You guys okay with that? And then what's 1 over cosine? And that's going to be, again, your what? right-hand side. So you got your left-hand side equals to your what? Right-hand side. Okay? Easy breezy lemon squeezy. And then what do you say? What about this one? Anybody know? What did you guys do this one here? Right? So you're going to have this here. Okay, do you guys see what I'm saying? So this is kind of I don't know about you, I really like this. You say, why would you like it so much? Well, because you get to use your what? If you're studying these formulas, you want to be able to use what you study. Sine of a difference over cosine of a difference. So what's sine of a difference? I think we used it. It's sine what? Sine cosine minus cosine sine. Is that right? Say sine. I mean, actually, if you guys really want to know the truth, let me teach you guys something about proof. You guys okay with this part so far? Okay. Did you know, what did we already prove? If you look back at the formula here, the cofunction formulas, right? And that's what they're called, cofunction. Sine 90 degrees minus theta is known as what? What is that equal to? That's cosine theta. Cosine 90 minus theta is what? Sine theta. Notice what I'm saying here. You can actually use that. Tangent is what? Oops. Yeah. You could use this. This is cosine over sine. Okay, and now what is cosine over sine? Isn't that what? Cotangent, which is the right-hand side. So here you go. Left-hand side is the right-hand side. There it is. You guys see my point? You say, what's your point, Mr. Judge? You had a formula for this. You can use it. There it is. You had a formula for what? For this. You can use it. And then you have a formula for cosine over sine being cotangent. And there you go. There it is. Easy breezy lemon squeezy. So, if you just look at this sheet, and I guess I'm going to have to check my home computer. go all the way down here. I'm going to update this when I get home. Essentially, if you said to me, Mr. Judge, what's there? What's the difference? What I did last night, and maybe I saved it in a different file, but I have to double check. What I did was delete questions like, well, here's some cofunction. You guys see some cofunction? And you got sine x minus pi. That's equal to minus sine x. You lose the difference formula again. You want to see an example of that one? Sine x minus pi. We'll look at that. I'll prove that for you guys just for completion. Because, I don't want to assume that you guys necessarily can do everything that you see here, although you should be able to by now when we see enough of these. But, I'm just sharing with you guys some of these, cofunction-ish, or using difference in sum formulas. So what I did last night is I actually deleted like this question, all of these, okay, because we didn't talk about them. So I deleted all those questions, and I replaced, from this portion down. All right, so I deleted them. So maybe I should actually delete this study guide now. So I don't want to get people to go, oh, that's the wrong study guide. I'm going to delete it now. And I put like power reducing, you know what I'm saying, that we worked on, power reducing. I put, what else did I put? I think, is that maybe it? I got to double check. So I deleted all this. So what I'm going to do, I'm going to say to you guys, I don't want people to get this study guide and go, oh, Mr. Judge, So I'll have to update it when I get home. Hopefully my wife lets me touch my computer, right? Daniel, you're working, I got to go to Costco. And that's how she got me last night. And I'm like, Sorry about that, Mrs. Judge. So all that work, all that work, and we don't benefit from it. Oh my gosh. Okay, you guys want to try this one? It's actually very simple. What's your left-hand side? The left-hand side will be what? Sine x minus pi. You guys okay with that? And then what's the difference formula again? You go, oh my God, I've seen this one over and over. I didn't think I wrote it. It's sine cosine minus cosine sine. Is that right? So sine cosine. So you say, is that sine x? Sine cosine minus what? Cosine sine. So what's cosine of pi? What's sine of pi? Isn't this minus sine x? Is that your right-hand side? So again, it's another 3 lines, ladies and gentlemen. Easy breezy, lemon squeezy. Easy breezy, lemon squeezy. There you go, minus sine. Butter. Yes. Oh, good question. Thank you. You see this number? This number is really what? 0. And then, so right in here, 0 times anything is 0. So in other words, that's what's going on for all of these. Like over here, same thing. See this? 0 times sine is 0. So that's going to happen. Even over here, look at this one. Cosine 0, cosine pi over 2 is 0. 0 times cosine is 0. So it's gone. It goes away. All right? You guys okay with that? Cosine 0 times sine. This is 0. It's gone. So what's going on here with these are very specially chosen. These aren't questions that what? They're chosen so that's going to happen. You guys see what I'm saying? So, but just always remember that, and you have a good question. 0 times anything will be 0. Okay? And here's another thing that's happening. 1 times anything is what? Is itself. Okay, you guys okay with that? It's a very good question. So what do you guys think? Does that make it pretty nice and easy? You guys see what I'm saying? So this is actually not too bad. And even like I said, some of these questions are on your test, so you guys know. That's why I'm going over it. Okay? That's why I'm going over it. And then some of these questions are on your test. You go, oh, yeah, because you've seen it in the practice test too, right? You guys see what I'm saying? So when I was going over this stuff last night, printing up your test and going over some of these things, I did that. And I got a few other ideas that I have I'm going to toss around too. But I'll post this stuff and communicate this to you guys, okay? So, I mean, I hope you guys stick by Canvas. You guys stick by Canvas? You guys have that app and something so you get it automatically? Because when I upload the correct version, I can't even find it here. So it was a long day. Yeah, heartbreaking. It's like I spent all that time, cleaning it up, and then it's not even there. Oh my God, who knows what happened? But anyway, I'll communicate to you guys this aspect, okay? But I just want to kind of share with you guys how I memorize this. This is like the Heron's formula is like the law cosine version of the area formula. And you need that square root of this. It's kind of beautiful. The semi-perimeter is a half perimeter. And that's the S, and it's prominent in this formula. And then here you got what? You got this is the other day. This is yesterday. And then you got the law of sines version, and that's important too. And then you do see them in other math classes and science classes. So that's kind of why it's important to me to test you on it and have that and get to as much as possible some of these things. So I'll do that for you guys, okay? All right. Anybody have any questions on what we've just done today with this cleanup? Did you guys enjoy proof, I hope? I mean, don't get intimidated by proof. This is a place in math where people get intimidated. And it's not as bad as people think. There's a lot of things you can see. I can spend another week or two on proof, in all honesty, but there's other things we got to get to. So, I hope you guys enjoyed that. And, we give you a little test on what day? Monday when you get back. I'll give you extra time. I'm going to be here early. Anybody care? So for those of you guys that want to get started earlier, what time? Don't tell me 5 a.m. I had trouble getting up this morning. I was a little late. I was a half hour late today, so I got in here like at 6:25. Usually I'm here at 6. So if you guys want extra time, I'm willing to give you guys extra time. How's that? But it has to be in the morning. What time does class start? So if you guys want to get started at 6:45, is that okay? If you're willing to do that, I'll give you guys an extra half hour if you guys like, just for comfort purposes. Okay, you guys okay with that? So I deleted that study guide, but most of it will be there only because I don't want confusion where people download it and they never check Canvas or they don't have it. And then they get stressed and they go, oh my God, I looked at the wrong thing. I studied the wrong thing. I studied inverse cosine because that's what you had. And you're a horrible person, Mr. Judge, for messing me up. And I'll just say, no, I'm just getting older. I'm not getting more horrible. I'm actually becoming more normal. I used to be abnormal, where I didn't make a single mistake the whole semester. That's like, wow. Now I can't go an hour without making a mistake. It's called being an old man. I apologize. Okay? So you guys take a look at that, study and work hard, and it's not going to be a surprise. And, have a great weekend and take care. All right? So you two at home, I hope you guys stay safe, and it's not raining anymore. So, try not to go outside and study these things, and we'll see you guys on Monday early if you want at 6:45. I don't design the test, so it's longer. I don't. So don't misunderstand me. You go, he just made that. No, I didn't I designed it within the time frame of an hour and 10 minutes. I'm just giving you guys extra time if you like. Okay? Because right after I have another class, and I can't give you extra time after that. Well, maybe. We'll see. Okay? Because I don't know how many people are going to show for that. So make sure you come early, though, at 6:45 if you want that extra half hour. All right? So we'll see you guys later. Have a great weekend.